Most of us spend our lives under this vast, ever-changing ceiling, but how often do we really look at it? Today, we're going to decode the sky. Because clouds are so much more than just puffs of water vapor. They're the language of the atmosphere, telling a story about what's happening right above our heads. Let's get into it.
And it's a story that directly impacts every single one of us, every single day. This quote really just gets right to the heart of it. From a beautiful sunny day to a massive summer thunderstorm, it all kicks off right there, inside a cloud. They're not just scenery. They're basically the engine room for our weather.
And that brings us to the big question, right? If clouds are like the atmosphere's fingerprints, what story are they actually telling? What do all these wisps and sheets and towering giants really mean? Well, that's what we're here to figure out.
Okay, so to read any language, you've got to understand its basic grammar first. So let's start at the very beginning. How are clouds actually born? At its most basic level, this is it. A cloud isn't some solid thing floating up there. It's a huge, visible community of unbelievably tiny water droplets or ice crystals all just hanging out together in the air. Sounds simple, right? But the real question is, how'd they get up there in the first place? Well, this slide breaks that whole magic trick down into a pretty simple three-step recipe. First, you need uplift. Some moist air has to start rising. Second, as that air goes up, it cools down. And third, once it's cool enough, the invisible water vapor in the air needs a little something to cling to, like a tiny speck of dust or pollen. And then poof, it condenses into a visible droplet. You do that millions and millions of times, and you've got yourself a cloud.
So what causes that crucial first step, the uplift? Well, there are three main ways this happens. Convection is what you feel on a hot summer day, when the sun heats the ground and sends these bubbles of warm air rising. Then there's frontal lifting, which happens when two different air masses smash into each other. And orographic lift, that's when wind just shoves air up and over a physical barrier, like the Pennine Hills in the UK. The key thing to remember is, without one of these lifts, the story of a cloud doesn't even get started.
All right, so now we know how they're born. Let's meet the main characters in our little sky story. Meteorologists classify clouds into different families based on two really key things: their shape and just how high up they are.
Think of this table as our decoder key. Way up high, like 6 to 10 kilometers, you've got the icy, wispy cirrus clouds. They're often the first little scouts telling you a change in the weather is on its way. In the middle, you have the alto family, which can look like a gray veil or a macro sky, also hinting a shift is coming. Down low, you get the boring sheet-like stratus clouds, which can mean drizzle. And then, you've got cumulus, the puffy cotton-like clouds that have, let's say, a bit of a split personality.
Let's just focus on that cumulus family for a sec to see how this works. On the one hand, you have the friendly, fair-weather cumulus. Those little cotton ball puffs that mean it's a nice day. But if that rising air is really powerful and keeps going, that same kind of cloud can grow vertically into an absolute monster. The towering cumulonimbus. It gets so tall it develops that flat anvil top where it literally hits the ceiling of the lower atmosphere. And this is the cloud that brings the thunderstorms. Same family, two very different stories.
And when I say monster, I really mean it. It's kind of hard to wrap your head around, but a single big cumulonimbus cloud can hold thousands of tons of water. That's the weight of several jumbo jets. So how does all that stay up there? Well, it's not floating like a balloon. It's actively being held up by the sheer force of the rising air currents beneath it. It's this constant dynamic battle between the power of that uplift and the pull of gravity.
Let's look at another one of these signals from the sky. Have you ever seen it look like this? This pattern is called a mackerel sky, and it's made of altocumulus clouds. It's one of those classic weather sayings for a reason. When you see this pattern, it's a pretty darn reliable sign that the weather is going to change, usually within about 24 hours.
Of course, the most dramatic part of this whole story is when those clouds just can't hold all that moisture anymore. So let's look at the climax of the plot, when the sky weeps and we get precipitation. Now, how rain or snow actually forms really depends on the temperature inside the cloud. In warmer clouds, it's basically a game of bumper cars. Tiny droplets bump into each other, they merge, they get bigger and bigger until gravity finally wins. But in cold clouds, it's a whole different story. Ice crystals form and they grow by basically stealing water vapor from the droplets around them. They eventually follow snow, or if they melt on the way down, as sleet or rain.
And then you've got drizzle. This slide makes a really important connection. Drizzle comes from those low stratus clouds precisely because they're so stable. They just don't have the strong vertical updrafts you need for droplets to collide and grow into real raindrops.
So all you get are these tiny, fine droplets that just fall slowly and create that miserable, persistent dampness.
So we have the grammar and we've met the main characters. Now, how can you actually use all this? Let's bring it all home by reading your own local sky.
This is a great example of how your local geography can write its own chapter in the weather story. In a place like Durham's Ware Valley, the landscape itself creates these unique conditions. On a cool, still autumn night, moisture in the valley just condenses right there at ground level. I mean, what is fog? It's just a stratus cloud that decided to form on the ground instead of way up in the sky.
So here's the bottom line. A cloud is never just a static object. It is the visible proof of what the air is doing. Is it rising fast? Is it stable and calm? Is it full of ice? Every single shape, every texture is a clue to these invisible forces that are at play all around us.
So the next time you step outside, just take a second. Look up. Those drifting shapes, they aren't just decoration anymore. The sky is telling a story of uplift and temperature and motion. And the best part is, now you know how to read it.